Hello everyone, welcome to OHM Institute. I am Surendra Reddy, Faculty for Electrical Machines at OHM Institute, Hyderabad. Today we will be discussing about a concept called slip calculations in three-phase induction motor. You ask any undergraduate student studying electrical engineering about the formula for slip in induction motor, you'll get an immediate reply because it is very easy and it is very easy formula to remember also. Slip S is equal to Ns minus Nr by Ns. But students who are preparing for competitive exams, you need to be very careful about calculation of slip. Why? Because always the same formula S is equal to Ns minus Nr by Ns may not give you the desired result in the examination questions. Why so? Why formula may be different? Slip formula cannot be always Ns minus Nr by Ns. That is true only if induction motor is excited from balanced supply and the motor started to rotate on its own, because three-phase induction motor is a self-starting motor. If a motor started to rotate on its own, automatically you can calculate the slip of the motor, which is Ns minus Nr by Ns. That is true. But there are some special cases where induction motor was not rotating on its own. Suppose an external prime mover is forcefully rotating the rotor, right? When external prime mover is involved, the rotor may be driven in forward direction or the rotor may be driven in backward direction. So there is a lot of difference between a self-rotating machine and external prime mover rotating machine. Yes, as I said, when the machine was rotating on its own, you can use a default formula for slip, which is Ns minus Nr by Ns. But when the machine was driven by an external prime mover, then the slip formula may change, because prime mover may rotate the rotor in forward or in backward direction. And again, there are two different cases we have to study. One is when motor is excited from stator side, that means stator winding is connected to supply, or when the motor is excited from rotor side, that means rotor winding is connected to supply. Especially in slip ring induction machines, rotor winding is accessible out of the machine. So we can excite the machine either from stator side or from rotor side. Okay, two cases: stator excitation, rotor excitation. And again we have two sub cases, right? Like prime mover is driving the rotor in forward direction, prime mover is driving the rotor in backward direction. Okay, so we will consider all these cases and we will try to solve some simple numerical questions where we can avoid our confusion. Okay, right, let's start it. Okay, so first I will consider what is the formula for slip. What is the basic formula? And don't do the same mistake. Don't say slip equal to Ns minus Nr by Ns. That is a default formula, but we are discussing some special cases. Therefore, we have to go to the actual definition for slip of an induction motor. So remember, the per unit slip of an induction motor is the ratio between slip speed and synchronous speed. Okay, this is a per unit quantity. Slip is always a per unit quantity. And we know that per unit quantity is the ratio between actual quantity to base quantity, where actual quantity and base quantity are of same unit, right? So slip is defined as the ratio between slip speed and synchronous speed. That's all. So now what exactly mean by slip speed? This is what we need to understand here. If you understand slip speed properly, that means you can answer any question. Okay, so to understand slip speed, I am going to consider two cases. First one is when motor is excited from stator side, and the second one is when motor is excited from rotor side. I am not going in detail of slip speed. I will give you a brief introduction so that you can answer any question. Okay, all right. In actual classes we use it to define slip speed in a conventional way, in-depth discussion, and then later we will come to formulas. But here briefly I will tell you so that you can answer questions easily. All right. Okay. So let's take the first case. The first case is induction machine is excited from stator side. Is excited from stator side. Okay, that means stator winding is connected to three-phase supply and the rotor winding is a closed circuit, right? So that means you take this. Suppose if this is the stator winding, a three-phase balanced stator winding, and this stator winding is connected to three-phase supply source, let's say with a sequence ABC. This is the stator part, and there is a rotor circuit also. Imagine it's a star connected rotor circuit, but a rotor winding is a closed circuit. All right, closed circuit. Now what is going to happen here? As we are giving excitation to stator winding first, imagine stator winding is supplied with a frequency equal to F1. The moment you give excitation to stator winding will draw three-phase balanced current, okay, IA, IB, IC. So whenever a three-phase distributed winding, we know in induction motor we will use distributed winding. Whenever a distributed winding excited with a three-phase balanced supply, immediately it will create a rotating magnetic field. So stator winding will create a rotating magnetic field, and that stator magnetic field will cross air gap and will link rotor winding. Okay, stator magnetic field will cross air gap. We know between stator and rotor there is an air gap. That stator magnetic field will cross air gap and link rotor winding. Therefore, a mutual EMF will be induced in rotor winding. This is like secondary induced EMF of a transformer. We know in the transformer also we will excite primary winding, and primary winding will create the main flux. That main flux will go through the magnetic core and link secondary winding, so that mutual EMF will induce in secondary winding, right? And self EMF will induce in primary winding. In a similar manner, we are exciting stator winding. So first stator winding will create its magnetic field. That magnetic field will cross air gap and link rotor winding, so a mutual EMF will be induced in rotor. That means indirectly, mutual induction is the action between what and what? It is the action between stator magnetic field and rotor winding. I repeat again, we are exciting stator winding, so stator field will produce first, that will cross air gap and link rotor winding. So mutual induction is the interaction between stator magnetic field and rotor conductors, and the relative speed between these two is what we call it as a slip speed. So therefore, what is the definition for slip speed? I can say it is the relative speed between stator magnetic field and rotor conductors, because between these two the mutual induction is taking place. Okay, so I can write slip speed. Slip speed, it is the relative speed between stator field and rotor conductors. Okay, it is the relative speed between stator magnetic field and rotor conductors. We know stator magnetic field will rotate at how much speed? Synchronous speed. Rotor conductors will rotate at how much speed? Nr. Nr is the speed at which rotor will rotate, and the relative speed between these two is what we call it as slip speed. Okay, this is the definition of our slip speed. And most important thing, this is the observation when we are exciting the machine from which side? Stator side. Okay, so we are exciting stator winding. Stator winding will create the flux first, that will cross the air gap and link rotor winding. So mutual induction is taking place between stator field and rotor conductors. Therefore, slip speed is the relative speed between stator field and rotor conductors, between which the mutual induction is taking place. And also you might have studied in induction machines operation already. If a supply frequency is equal to F, let us say F, to avoid confusion, let's say supply frequency is equal to F, then what will be the induced EMF or mutual induced EMF frequency? That is known as a slip frequency S into F. I am not going in detail how that slip frequency will come and all. Our intention is to calculate the slip. I hope you have idea about this concept. If a supply frequency is F, then what is the rotor frequency of the machine? Slip frequency SF. Okay, so that's all. This is when the machine is excited from which side? Stator side. Okay, now let me go to another conclusion. What happens if the same induction machine is excited from rotor side? Okay, induction machine excited from rotor side. Induction machine excited from rotor side. So imagine this is a slip ring induction motor. Remember, only in a slip ring induction motor, rotor winding is accessed outside and you can excite. Okay. So imagine this is the rotor part of the induction machine. Okay. So having supply terminals this side. So machine is excited from rotor side and stator winding is short circuited. Okay. This is the stator part which is a closed circuit. Okay. Now let's see what is going to happen. So this time we are giving supply to which winding? Rotor winding. As we are giving supply to rotor winding, can I say rotor frequency is nothing but supply frequency this time? And remember, supply frequency is always constant since it is infinite busbar frequency. So rotor frequency is equal to supply frequency. And this rotor winding will draw three-phase balanced current IA, IB and IC. And we know that whenever three-phase balanced distributed winding carrying three-phase balanced current, it will create a rotating magnetic field, right? So therefore, rotor winding will create a rotating magnetic field. And that rotor magnetic field will cross air gap and will link which winding? Stator winding. Okay, I repeat, we are exciting rotor winding first. So rotor field will create first. That rotor field will cross air gap and link stator winding. Therefore, mutual EMF will be induced in stator winding this time. Mutual EMF is induced in stator winding. Self EMF will be induced in rotor winding because machine is excited from rotor side. Therefore, if I ask you now, mutual induction is the action between what and what? Rotor magnetic field and stator winding. You understand that? In the previous case, mutual induction is the action between stator magnetic field and rotor conductors. So here stator is excited. So first stator field will create. That stator field will link rotor winding. So mutual induction is the action between stator field and rotor conductors. But now we are exciting the machine from rotor side. So first rotor field will create. That rotor field will cross air gap and link stator winding. So mutual induction is the action between rotor magnetic field and stator winding. Therefore, how to define slip speed now? For a moment, you please forget the formula called ns minus nr by ns. We will define it later. First, understand what is slip speed. So when the machine is excited from rotor side, between which elements the mutual induction is taking place? Mutual induction is taking place between rotor field and stator conductors. Therefore, slip speed is defined as relative speed between rotor field and stator conductors. Relative speed between rotor field and stator conductors. In the previous case means when the machine is excited from stator side, slip speed is the relative speed between stator field and rotor conductors. But now it is the relative speed between rotor field and stator conductors. And the moment when you know slip speed, you can immediately calculate what is the value of slip, because S is equal to slip speed by synchronous speed. Understand? And one more point. We are exciting the machine from rotor side. So what is rotor frequency? Rotor frequency is slip frequency or supply frequency? Yes, this time the rotor frequency will be supply frequency and mutual EMF is in stator. So stator frequency will be equal to slip frequency. Suppose if the excitation was given to stator winding, stator frequency will be supply frequency and rotor frequency will be slip frequency. But now rotor frequency is a supply frequency and stator frequency will be slip frequency. Understand? So if you understand this concept, any question you can solve related to this matter. Okay. So point is very simple. Slip is defined as slip speed divided by synchronous speed. But what is a slip speed is the question. Okay. If the machine is excited from stator side, slip speed is defined as the relative speed between stator field and rotor conductors. If the machine is excited from rotor side, slip speed is defined as the relative speed between rotor field and stator conductors. Okay. Now we will try to answer few questions, which are very useful for the upcoming GATE exam, AE exam, AW exam, whatnot. Every competitive exam will have these type of questions. Okay. All right, let's check them out. All right, so we have a question here, very important model, and this question model was repeated in many exams as well. So first understand the problem. A 3-phase 4-pole 50 Hz induction machine driven by an external prime mover at 1200 rpm in the direction of rotor magnetic field. Rotor winding is excited from 50 Hz source. The value of stator EMF frequency is what? So the key points you need to understand here is that machine was not rotating on its own. An induction machine driven by an external prime mover. Okay, it was driven by an external prime mover at how much speed? 1200 rpm. So this 1200 rpm is nothing but rotor speed, nr. Okay, the speed at which the machine is rotating. And another thing is that machine was driven in the direction of rotor field. Okay, suppose if rotor field is in forward direction, machine was also driven in forward direction only. Okay, if a rotor field is in backward direction, the machine was also driven in backward direction, like that. And one more information is rotor winding is excited from 50 Hz source. That means the machine is excited from stator side or rotor side? Yes, the machine is excited from rotor side. As the machine is excited from rotor side, slip speed is the relative speed between what and what? Rotor field and stator conductors. And finally, what is the answer we need? What is the value of a stator EMF frequency? Stator EMF frequency means now supply frequency. Sorry, slip frequency. Why? Because machine is excited from rotor side. Therefore, rotor frequency is a supply frequency and stator frequency will be slip frequency. That is the answer we need to find. So to calculate slip frequency, first we need to calculate slip. To calculate slip, we need slip speed. And what is slip speed in this case? As the machine is excited from rotor side, slip speed is defined as the relative speed between rotor field and stator conductors. Alright, so let's try to answer that. So please take a screenshot of this problem and try to solve it on your own once you finish this lecture. Okay, just to look at that. Machine is driven by an external prime mover at 1200 rpm in the direction of rotor field. In the direction of rotor field. Okay, so let's note down what was the data given in the problem. So machine has 4 poles and supply frequency is equal to 50 Hz and machine was driven at a speed of 1200 rpm. Okay, and which winding is excited? Rotor winding is excited. So calculate the synchronous speed first. We know the formula for synchronous speed is 120 f by p. 120 into what is the supply frequency? 50 by 4. This will give you 1500 rpm. Can I say this is the speed of which field? Most importantly, which frequency I am using? Supply frequency. Supply frequency was given to stator or rotor? Rotor. Therefore, this is rotor field speed. Indirectly, this is rotor field speed. Rotor field speed with respect to rotor, obviously. Suppose if you use a stator frequency here, then it will become stator field speed with respect to stator. As I am using rotor frequency here, it is rotor field speed with respect to rotor. And one more additional information here is that rotor was driven using an external prime mover at 1200 rpm in the direction of rotor field. In the direction of rotor field. First you need to understand what is the direction of rotor field here. Is there any information in the question about the sequence of the supply? No. When nothing is given, by default what is the sequence you will consider? You will consider by default A, B, C sequence. Am I right? Positive sequence. Suppose in the question it was clearly mentioned ACB sequence or negative sequence, then only you have to consider it. Otherwise, by default it is a positive sequence supply. And we know that positive sequence supply means field will rotate in forward direction or backward direction. Yes, we know in induction motor using a positive sequence supply can rotate the field in forward direction. Using a negative sequence supply can rotate the field in backward direction. That means this rotor field is now rotating in forward direction. Now let us take a stationary object here, stator. Imagine this line is a stationary line. Now field is rotating in forward. So what I am doing in this plane, in this plane, I am assuming right side is like forward direction movement then left side movement will be definitely backward direction movement. Okay, or you take right side backward movement, left side forward movement, anything. But it's a general practice taking movement to the right side of a stationary object is forward movement, movement to the left side is a backward movement. So tell me now, rotor field is now rotating in which direction? Forward direction means, can I say to the right side? If rotor field is moving to the right side, indirectly can I say rotor is also driven to the right side only, because it was given induction machine is driven by an external prime mover at 1200 rpm in the direction of rotor field. It is in the direction of rotor field. Field is in which direction? Forward direction. That means indirectly the rotor was also driven in forward direction. So let us try to draw a simple diagram now. Now see this, all of you. Assume this is a stationary line. Okay, this is a stationary line means, can I say this is the stator part of the machine? We know stator is always a stationary. On this stator part, imagine stator winding is there. Stator winding is a three-phase balanced winding. Okay, and the stator winding is excited or a rotor winding is excited? Remember in the question, rotor winding is excited. Stator winding is a closed circuit. Now the question is, rotor is rotating in forward direction or backward direction? Yes, it was given in the question, rotor was driven by an external prime mover in the direction of rotor field. And the rotor field is in forward direction. That means indirectly the rotor was also rotating in forward direction. Forward means right side. So see this. This is the position of the rotor. This is these three circles represent three-phase rotor winding. Okay, why rotor is rotating to the right side only? Because rotor was rotating in the direction of rotor field. Rotor field is in forward direction. That's why rotor was also driven in forward direction. This is NR. NR means the speed at which the rotor was rotating. Okay. Now this rotor winding is excited using a supply, ABC sequence supply. When nothing was given, we have to assume positive sequence. And whenever a three-phase balanced winding excited with balanced supply, it will create a stationary magnetic field or rotating magnetic field. Yes, rotor will create a rotating magnetic field, rotor field. And rotor field is in which direction? Forward direction from rotor. And what is the speed of magnetic field? That is nothing but synchronous speed. This is synchronous speed. So this is the position of rotor or rotor field. Yes, this is the position of rotor field. Okay, so what is the speed of rotor field with respect to rotor? That is nothing but ns. We already calculated what is the ns value. Yes, ns is the speed of rotor field. Why ns is not the speed of stator field? Because remember in this question, machine was excited from rotor side. Okay, so supply frequency is rotor frequency. That's why this is the speed of rotor field. What is the speed of rotor field with respect to rotor? That is nothing but ns. Okay, that's what. So look at this diagram. This is the position of rotor or rotor field? Rotor field. So what is the speed of rotor field with respect to rotor? Ns. Okay, and it is in which direction? Forward direction. As rotor field is in forward direction, rotor was also driven in forward direction, because in the question it was clearly mentioned rotor was driven in the direction of rotor field. Okay, now finally we have to calculate a slip speed here. I already told you, as the machine is excited from rotor side, what is the slip speed definition? Slip speed is defined as the relative speed between rotor field and stator conductors, because machine is excited from rotor side. So rotor will create the field first, that will cross air gap and link stator winding. So mutual induction will happen in stator winding. It is the interaction between rotor field and stator conductors. See, rotor field is here. This line is rotor field position. This is rotor field. And where are stator conductors? Can I say stator conductors are here? So slip speed is defined as the relative speed between rotor field and stator conductor. That means, can I say this whole distance? And what is this whole distance? This is NR, this is NS. Therefore, can I say the whole distance is equal to NS plus NR? That is the relative speed between what and what? Rotor field and stator conductors. Okay. So finally, what is the slip speed in this particular problem? Slip speed is equal to NS plus NR. What is NS in the given question? 1500. NR is 1200. Machine was rotating at 1200 rpm. Therefore, this was 2700 RPM. This is a slip speed. If you know slip speed, how to calculate per unit slip? Per unit slip is always slip speed divided by synchronous speed. So which is equal to 2700 divided by synchronous speed 1500. Therefore, 27 by 15, which is 9 by 5. This is per unit slip. But what is the ultimate answer we have to find? Yes, the answer that we need is what is the stator EMF frequency. As a supply was given to rotor, stator frequency is nothing but slip frequency. And what is the formula for slip frequency when you know slip? It is S times of supply frequency. Therefore, the frequency of stator is equal to slip frequency, which is 9 by 5 into supply frequency 50. The answer is 90 Hz. Okay, so therefore the answer for this question is option B, which is 90 Hz. But I'll tell you, most of the students will do a common mistake. They will directly consider S is equal to Ns minus Nr by Ns. Ns is 1500 in the question, Nr is 1200. 1500 minus 1200 by 1500, you will get a different slip and you will get 10 Hz as the answer. That is also available in options. Okay, so don't do any mistakes. So point here is very simple. Machine was not rotating on its own. An external prime mover is rotating the machine. And the machine is excited from stator side or rotor side. Machine was excited from rotor side. Whenever machine is excited from rotor side, slip speed is defined as the relative speed between rotor field and stator conductors. Whenever machine is excited from stator side, slip speed is defined as the relative speed between stator field and rotor conductors. Okay, and also it is very important in which direction the machine was rotating. It was clearly mentioned the machine is driven by an external prime mover at 1200 RPM in the direction of rotor field. In the direction of rotor field. First of all, understand in which direction the rotor field is moving. Forward direction. As rotor was moving in forward direction, indirectly rotor was also driven in the direction of rotor field, that is forward direction. Okay, all right. Let's take one more example so that it will be more clear. Okay. Okay, so we have one more question. It is almost same as the previous question, but a slight modification. Okay, so go through this question. A 3-phase 6-pole 60 Hz induction motor is excited from rotor at rated frequency. If rotor is driven opposite to rotor field at 1000 RPM, what is the stator frequency is? Okay, it's almost like previous question. Machine is once again excited from rotor side. See, induction motor is excited from rotor side. As a machine is excited from rotor side, what is the slip speed? It is the relative speed between rotor field and stator conductors. Okay, and machine is rotating. If rotor is driven, machine is not rotating on its own, an external prime mover is rotating this machine. That is the meaning of it. If rotor is driven opposite to rotor field, this is important. The rotor was driven opposite to rotor field at 1000 RPM. Okay, then what is the stator frequency is the question. As a supply was given to rotor, can I say stator frequency is nothing but slip frequency, obviously. So to calculate slip frequency, first we have to calculate what is the value of slip. And slip is the ratio from slip speed to synchronous speed. And in this case, as the machine is excited from rotor side, slip speed is defined as the relative speed between rotor field and stator conductors. Okay, all right, let's try to answer the question. First, understand what was the data given. The machine has 6 poles. Supply frequency to rotor is 60 Hz. And the machine was driven at 1000 RPM. So calculate what is the synchronous speed first. Ns is equal to 120 F by P, where F is nothing but supply frequency. And here supply frequency is stator frequency or rotor frequency? Rotor frequency. That's why we are getting rotor field speed. So if I substitute the data, 120 into supply frequency 60 by 6 poles, this is 1200 RPM. Importantly, this is the speed of what? This Ns is the speed of rotor field. It is the speed of rotor field with respect to rotor or from rotor with respect to rotor. Okay, if you use a supply frequency as a stator frequency, then you will get stator field speed. We will solve one question like that, but currently we are solving the question where a rotor is excited. Therefore, this is the speed of rotor field with respect to rotor. Okay, but important thing is that rotor was rotated in the direction of rotor field or opposite direction of rotor field? Opposite direction. First tell me, rotor field will rotate in which direction, forward or backward? It depends upon sequence. But there is nothing given about sequence in the question. That means by default we have to consider positive sequence. Therefore, rotor field is rotating in forward direction, positive sequence. If rotor field is rotating in forward direction, rotor is driven in backward direction because it was given rotor driven opposite to rotor field. Opposite to rotor field. That means rotor was driven in backward direction at how much speed? 1000 rpm. So let's draw a diagram here. So I am taking a stationary line. This is like stator part. Remember, stator is always stationary. And we have a three-phase stator winding. So I am drawing three circles to represent three-phase winding. And the stator winding is excited or stator winding is a closed circuit. In this question, stator winding is closed, rotor winding is excited. And the rotor field is rotating in which direction? Forward direction, because positive sequence. But rotor was driven in backward. Rotor field is rotating in forward direction, but rotor conductors are driven in backward direction because it is opposite to rotor field in the question. So forward means right side, that means can I say backward means left side? So rotor was driven in the backward direction. This is the position of rotor and rotor winding. At what speed rotor is rotating? Nr. In forward direction or backward direction? Yes, rotor was driven in backward direction at Nr speed. Okay. Now this rotor winding is excited using a positive sequence supply. Whenever a three-phase balanced winding is excited using a positive sequence supply, it will create a rotating magnetic field. And what is the speed of that rotating magnetic field? Synchronous speed. And that synchronous speed is in forward direction or backward direction? Forward direction, because it is positive sequence. Forward direction means, can I say it is to the right side from the rotor? Please don't confuse, guys. The most of the times students will confuse, this is the speed of rotor field with respect to stator. Actually, this is the speed of which field? What is this frequency? This frequency is rotor frequency. Therefore, this is the speed of which field? Rotor field. But from where? That is important. It is the speed of rotor field from rotor, not from stator. Suppose if you use a stator frequency here, you will get the speed of stator field from stator. But this is rotor frequency, therefore you will get rotor field speed from rotor. Okay, what is the answer? 1200 rpm. So this is rotor. From rotor, the rotor field is rotating in forward direction. Okay, ABC sequence. At how much speed? Synchronous speed. This is the position of rotor field. Don't forget, this is the position of rotor field. So answer the final questions. What is the speed of rotor field with respect to rotor? Ns, 1200 rpm. What is the speed of rotor with respect to stator? This is Nr, this is 1000 only. This is 1000, but this is 1200, that's why it is crossing this line. Okay. So finally tell me, what is the slip speed now? As a machine is excited from rotor side, slip speed is defined as the relative speed between rotor field and stator conductors. Look at this. This is rotor field position. This is rotor field. Here you have a stator conductors. Can I say the relative speed between these two is nothing but the slip speed? And tell me right now, what is this distance is equal to? This is Ns, this is Nr. Therefore, can I say this half is nothing but Ns minus Nr? Therefore, in this particular question, the slip speed is Ns minus Nr. If slip speed is Ns minus Nr, then what is the slip value? We know S is equal to slip speed with respect to synchronous speed. Slip speed is right now Ns minus Nr. Therefore, Ns 1200 here, Nr 1000 divided by 1200. So, you'll get 200 by 1200, that is 1 by 6. Okay, if a slip is 1 by 6, then what is the stator frequency? That is nothing but the slip frequency. S into F 1 by 6 into 60 hertz supply, therefore the answer is 10 hertz. The stator frequency in this case is 10 hertz, therefore the answer is 10. So very important problems, okay, and you will get one of these model definitely in any competitive exam, coming GATE or AEE or AEE, any exam, okay. So don't always go with a formula like ns minus nr by ns always. That is always not true. That is true only if the machine was rotating on its own. Okay, you give supply to induction motor, you just leave the machine, machine will automatically rotate, then the formula will be valid, ns minus nr by ns. But when the machine is driven by some external prime mover, the same formula may not be valid. In that case, you have to go through the definition of the slip. It is the ratio between slip speed to synchronous speed. Okay, so two problems we solved. Okay, in both problems, machine is excited from which side? Rotor winding side. Okay, now let's take one more example where the machine is excited from stator winding side. Okay, right. All right, so we have one more example with us now. Just read this problem. A three-phase 4-pole 50 Hz induction motor is excited from stator. Machine is excited from stator at rated frequency. If rotor is driven by an external prime mover at 1440 rpm in the opposite direction of stator field, the frequency of rotor EMF is how much? That's the problem. So the key points that we need to understand here are machine is excited from which side? Machine is excited from stator side. If a machine is excited from stator side, what is the slip speed definition? It is the relative speed between stator field and rotor conductors. Okay, right. And one more important thing is, if rotor is driven by an external prime mover, rotor is not rotating on its own, an external prime mover is rotating the rotor at how much speed? 1440 rpm in the opposite direction of stator field. This is important. In the opposite direction of stator field. Okay. Then what is the frequency of a rotor EMF? Point is, we are giving supply to stator winding, therefore stator frequency is supply frequency. That means, can I say rotor frequency is nothing but slip frequency? Alright, let's see how to answer. So key points are, machine is excited from stator side, rotor is driven by an external prime mover. In which direction? In which direction? Opposite direction to stator field. Opposite direction to stator field. What is rotor frequency? Okay. So let's note down what is the data given in the problem. Yes, the machine has 4 poles and the supply frequency is equal to 50 Hz. Rotor is driven at a speed of 1440 rpm. So first calculate what is the synchronous speed. What is the formula for synchronous speed? 120 F by P. This is equal to 120 into what is the supply frequency? 50 by 4 poles, which is equal to 1500 rpm. Now important thing is, this supply frequency is now stator frequency or rotor frequency. Remember, machine is excited from stator side, therefore this is a stator frequency. As this is a stator frequency, this is the speed of which field? Stator field. Okay, so it is the speed of stator magnetic field. Okay, it is speed of stator field. Stator field from where? With respect to stator. With respect to stator. Suppose if you use rotor frequency here, suppose if the machine is excited from rotor side, supply frequency will be the rotor frequency, then you will get the speed of rotor field with respect to rotor. This is the speed of stator field with respect to stator, obviously. Okay. Now try to answer what is going to be the question. Okay. So let's take a stationary line now first. This is the stator part. Stationary line, this is stator. Stator is always stationary. And we have a 3-phase stator winding here. Important thing is, stator winding is a closed circuit or stator winding is excited? Yes. Supply was given to stator winding, ABC sequence. Remember, when nothing was given, by default the sequence is ABC. As it is ABC sequence, stator winding will create a magnetic field in forward direction or backward direction? Forward direction. Okay. But forward means right side. So stator field is rotating to the right side, forward direction. But rotor was driven in the direction of stator field or opposite direction. See, the rotor is driven by an external prime mover at 1440 rpm in the opposite direction to stator field. Stator field is in which direction? Forward direction. Therefore, rotor was driven opposite to stator field means, can I say backward direction? So, rotor was driven in the backward direction. This is the position of rotor. At what speed? Nr. Okay. So, rotor is driven in the opposite direction because stator field is in forward direction. So, where is the stator field now? We already found the speed of stator field with respect to stator. This is stator. From stator field is at how much speed? 1500 rpm. In which direction? Forward direction. This is stator. So now this is the position of stator or stator field? Stator field. What is the speed of stator field? Ns. The speed of stator field with respect to stator, that is ns. But rotor was driven in the direction of stator field or opposite direction? Opposite direction. This was given in the question. Alright. This is where the rotor conductors are. Now finally tell me what is meant by slip speed here. Slip speed is always defined as, yes, when you give excitation to stator, slip speed is the relative speed between what and what? Stator field and rotor conductors. So remember, stator field is here, rotor conductors are here. Can I say the distance between these two is the relative speed? That is the slip speed. It is the relative speed between stator field and rotor conductors. What is this whole distance? This is already ns, this is nr. So can I say the whole distance is equal to ns plus nr? That is the slip speed now. Okay. Once you know what is the slip speed, you know how to proceed to find out the answer. So now slip speed is equal to ns plus nr rpm. Then what is the formula for slip? It is the ratio from slip speed to synchronous speed. Here ns is 1500, nr is 1440 divided by 1500. Okay, you'll get 1.96. If you know slip, what is the rotor frequency? Yes, don't forget that supply is given to stator, therefore rotor frequency is equal to slip frequency. 1.96 into 50, which is 98 Hz. If there are any mathematical mistakes, please you can correct them. Okay, so that's it. So if you understand this basic concept, you can answer any question. Don't always remember, sir, same direction means ns minus nr by ns, opposite direction means ns plus nr by ns. If you try to by heart those formulas, you will definitely end up with wrong answers, especially when machine is excited from rotor side. If machine is excited from stator side, no problems. Same direction means ns minus nr, opposite direction means ns plus nr, that formulas are valid. But when the machine is excited from rotor side, you will end up with mistake, and that wrong answer will be available in options also. Okay, that's why whenever machine is driven by an external prime mover, think about the definition of the slip. It is the ratio from slip speed to synchronous speed. But remember, try to remember what is slip speed. If the excitation was given to stator, slip speed is the relative speed between stator field and rotor conductors, because between these two mutual EMF is taking place. When a machine is excited from rotor, slip speed is defined as the relative speed between rotor field and stator conductors. Between the two, the mutual induction is taking place. Okay, that's all. This is about important slip calculations in three-phase induction machines. Especially when a machine is excited from rotor, the problems are important. The first two examples I solved are when machine is excited from rotor side. Okay, thank you.